Hello students, I Gopabandhu Mehe PGT Physics Web Cheka. Welcome you all to today's class. First, let's see today's class overview. Today we pass alternative current in a circuit containing inductor and here in this topic we will be first finding the expression for current, expression for alternative current, then we will find the phase difference between alternating EMF and current. Then we will plot the graph of alternating EMF and current with versus phase angle omega t, and finally we represent the current and alternating EMF in phase diagram. So let's discuss today alternating current in an AC circuit with inductor. Let's consider one inductor having coefficient of inductance L. Then we'll supply some alternating EMF source to this. Let's consider alternating EMF source E. Then alternating EMF can be given by E is equal to E naught sin omega t. Let this will be equation 1. Then due to this alternating EMF, some alternating current will be passing through the circuit, which will change its magnitude and direction. And due to this change in magnitude and direction, some back EMF will be set up in the inductor. Back EMF, let this will be E. Why this will be set up? Because we know that when current passes through an inductor, then magnetic field B can be given as mu naught and I, where your mu naught is equal to permeability of free space in the inductor, and N is equal to number of turns per independent, N by N, number of turns per independent. So you see that this B is directly proportional to I. B is directly proportional to I when N and mu naught is constant. It means when this current will change, when current in the circuit will change, then magnetic field linked with the inductor will change. And according to Lenz's law, whenever there is change of magnetic field with respect to the circuit, linked with the circuit, then some EMF is developed which tries to oppose the change, which produces the change. Then this back EMF can be written as E is equal to minus L di by dt, and di by dt represents your rate of change of current multiplied by the self inductance. Then by applying Kirchhoff's law in this circuit, by applying Kirchhoff's voltage law in the circuit, we can write that net potential, net change of potential in the circuit will be equal to 0, or this external EMF plus the EMF what is set up, that is going to be 0. So this implies your E plus, in place of E, if you write the value of the E, then it is minus L di by dt. So this is going to be 0. This implies E is equal to minus when you take on the right hand side, so it is going to be L di by dt. By putting the value of E in this equation, we will get E naught sin omega t, that will be equal to L di by dt. And our purpose is, our aim is to derive expression for this current, alternating current. So how can we derive this? Let's take this di on left hand side, then this implies di is equal to E naught divided by L. When you take this L to left hand side, it will be divided by L, then part of left hand sin omega t and then dt. Now to get the current at any moment, we have to integrate this small current at any interval dt. So this implies I is equal to integration of di, that will be equal to, when you integrate the right hand side, at E naught by L is constant, so let's take this one outside, then we will integrate sin omega t. Then we will be finding the integration of this. Now let's integrate this sin omega t to get the current. So for this, I is equal to E naught by L, then integration of sin omega t is equal to your cos minus cos omega t and divided by omega, because integration of sin at is equal to minus cos at divided by t. So this is formula you must have read in mathematics. Then this can be written as I is equal to E naught divided by omega L. So this L and omega multiply, minus let's take outside, then this is cos omega t. Now because our alternating EMF is in the form of sin omega t, and what we have got the expression is in the form of cos omega t. So to change this cos, so to write this cos omega t in the form of sin omega t, so that we can compare the both the quantities, then we can write I is equal to minus E naught by omega L, then this is cos theta, so cos theta can be written as sin 90 minus theta. Okay. Now when we multiply this minus inside, then we can write I is equal to E naught divided by omega L, and this will be sin omega t minus pi by 2, because we know minus sin theta is equal to sin of minus theta. Okay. Then this equation can be further written as I is equal to I naught sin omega t minus pi by 2, where your I naught is equal to, where I naught is equal to E naught divided by omega L. If you notice here, I is equal to your E by R, because we know that I is equal to E divided by R. So it means then the second, the denominator part representing some resistance offered by the inductor, and that resistance is known as your inductive resistance, inductive reactance. Resistance offered by the inductor is known as inductive reactance. So this can be written as inner divided by xi, where your xi is equal to inductive reactance, and this will be equal to your omega L. Okay. Then this I equal to I naught sin omega t minus pi by 2. Let's take this equation 2. Then in equation 1 we had got E is equal to E naught sin omega t. If you recall, our expression for the alternating EMF was E is equal to E naught sin omega t, and now equation for the current what we have got, that is equal to I naught sin omega t minus pi by 2. So by comparing these two equations, we can write. So comparing equation 1 and 2, we can see that compare both the equation. Here sin omega t is present, here also sin omega t is here, but one extra term comes, that is minus pi by 2. So this minus pi by 2 will represent our phase difference. So there is phase difference between the current and alternating EMF. So comparing equation 1 and 2, we can conclude that current, because the phase difference comes as minus, it means it lags behind the alternating EMF. So the current lags behind the EMF by a phase of pi by 2, or phase difference between EMF and I, phase difference phi is equal to minus pi by 2. So next we will be drawing the graphical representation of E, electromagnetic force, and alternating current I with respect to phase angle omega t. So for this purpose, let's draw x-axis and y-axis. On the x-axis, we will be taking the phase angle, so omega t on x-axis, and alternating EMF or current will be taking on the y-axis. So for one complete cycle, let's represent the phase angle. So first one is pi by 2, then let's take pi, then 3 pi by 2, and then 2 pi. Then on the y-axis, the maximum value of the EMF, that will be represented by this line. So now to represent the EMF, E is equal to as E naught sin omega t. Let's represent the EMF and current in a tabular form. So E, let's take phase phi, and the values of E and I. First pi is equal to 0, then pi by 2, then pi, then 3 pi by 2, and then at last it is 2 pi. So when phi is equal to 0, then E is equal to inner sin omega t. So in place of omega t, when you put 0, then the value will be 0. Then when you put pi by 2 here, pi by 2, sin pi by 2 is 1. So then the result of E will be maximum, that is inner. Then when you put again pi, they are negative 0. And when you put 3 pi by 2, then it is minus 1 sin 3 pi by 2 will be your minus 1. So E will be equal to minus inner. And again when it is 2 pi, then that is 0. Okay, so let's plot the graph for E is equal to inner sin omega t. So first it will get 0. Then negative maximum value, let's take again on the negative y-axis, and this will be the line suppose. Then when phi is equal to 0, then EML is equal to 0. Then for pi by 2, it is maximum. So this is going to be the maximum. Then again at pi, it is 0. So this will be the point. Then at 3 pi by 2, E is equal to minus inner. So then this value will be then minus inner. And again at 2 pi, the value is 0. So when you draw the graph, you will be getting then sine curve, and this is the sine curve. Okay, the sinusoidal curve will get. Then when you plug the graph for the current, because our current I is equal to I naught sin omega t minus pi by 2. Now when you put in place of omega t 0 first, then this part is your 0. So sin minus pi by 2 and sin minus pi by 2 is your, this value is minus 1, means this I will be equal to our minus I naught. So then it is minus I naught first. Then when you put pi by 2 in place of omega t pi by 2 minus pi by 2, so that is 0. So sin 0 is equal to that 0. So I is equal to that 0. In the same way, when you put pi, then it is pi minus pi by 2. So the result will be pi by 2. Sin pi by 2 is 1. So I will be equal to I naught. And again for the 3 pi by 2, this will be 0. Okay, and for 2 pi, that is going to be minus I naught again. Minus I naught. So when you plot the graph of I, then first at 0 phase, the value of I is equal to minus I naught. It means if we take I naught, suppose here plus I naught and minus I naught to be here. Why have I taken the I naught less than the E naught? Because we know always I is equal to our E by R. And when you divide by some positive resistance, not the decimal, at that time we are going to find I to be less. Okay? Because after getting the division from I, we will be getting I. After getting the division from E, we will be getting the I. So we assume that I is less than E. Then, so first at 0 phase, the value of the I is minus in I naught. Then at pi by 2, it is 0. Then at pi, it is plus I naught. So this is going to be our plus I naught. So where is the plus I naught? Then this part will be the plus I naught. Then again at 3 pi by 2, it is 0. And at 2 pi now, it is again again minus n. So this so much. So when you join these points, then you will be getting this curve. This is again sinusoidal curve. Okay. So this curve. So this represents the first curve represents your E, and second curve represents the current, alternating current. So here what you have to notice that, how to remember, we know the graph of E, it is sinusoidal graph. But when we look the current, here phase difference of minus pi by 2 present. So as it is minus, always you have to start the graph from the negative y-axis. Remember like this. So you have to start from the negative y-axis. Okay. Then you will get the current graph. Now you have to understand that how current lags behind the alternating EMF. What is meaning of this? That whatever value is achieved by the alternating EMF, that value is achieved by the current at a later phase of pi by 2. मतलब pi by 2 phase के बाद जाके वो achieve करेगा. So let's see that. First look the minimum value. Minimum value of the alternating EMF, that is 0, and you see that this is achieved at phase equal to 0. Okay, or initially it is achieved. Then, but what you observe now, that minimum value is achieved by the current, because this is the current curve. That minimum value is achieved by the current at a later phase of pi by 2. pi by 2 के बाद जाके अचीव किया. ओके, EMF पहले से अचीव कर चुका था. Well, और this phase difference is pi by 2, or time when we take that, it is t by 4. Okay, because total time period is t. So current lags behind the voltage by phase of pi by 2. You may take the maximum value also. Look the maximum value that is achieved by the alternating EMF at a phase of pi by 2, but that is achieved by the maximum value is achieved by the current at a later phase of pi by 2. After pi by 2, the current has achieved the maximum value. Look at this is the maximum value what is achieved by the current at a later phase of pi by 2. Okay. Then next will be present phasor diagram of alternating EMF and current. So for that purpose, phasor diagram. Let's draw x-axis and y-axis. Then as usual, we know that alternating EMF can be represented by rotating vector E, and at any moment the phase is suppose omega t. Now as the current lags behind the alternating EMF, so this current has to appear behind this alternating EMF, and we know that the phasor rotate always in anti-clockwise direction with angular frequency omega. So whatever will be coming advance of this left side of the E, or in anti-clockwise direction of the E, so that will be E hat. But you have to represent the back of the alternating EMF, so we will represent that on the clockwise side. Means when we represent this one here, and the length will be smaller, length of the current will be smaller, because you know this length represents the maximum value of the phasor. So this will represent the current then, and the angle between E and I will be 90 degree. So you draw these in such a way that this will appear to be